Hello, guys. Hello, everyone. Let's look at some structural questions on state of matter from your chemistry IGCSE past papers. It's very easy, so there's nothing to worry about. Matter can exist as solid, liquid, or gas. The arrows show some changes of state. So you have your solid particles there, liquids, as well as your gas. Name the changes of state represented on the diagram. The changes of state represented on the diagram. So your A should be your melting. Check it out. Your solid to your liquid should be melting. So put my melting here. This is E. Oh, I don't like my spellings. So this is your melting. Now your B is from solid to your gas, and that's sublimation. And finally, your gas to your liquid is condensation, right? Condensation. So let's check again. Your gas to your liquid, condensation. Your solid to your liquid, sublimation. And of course, or your solid to your gas, sublimation. Then your solid to your liquid is melting. Good. Let's continue. Explain why energy has to be supplied to turn a liquid into a gas. Now, the heat is actually applied there to overcome or break down the forces of attraction. So heat is applied to overcome the forces of attraction between the liquid particles, okay? Is my there not well written? So I can put it on the line. To overcome the forces of attraction between the liquid particles. I don't know. I can't use my mouse to bring this down. So just use. Now the C part has two volumes, D and E. One is a larger volume and the second one is a smaller volume with gas particles in each container. The two containers are at the same temperature. In which container will the pressure be higher? Explain your answer. So the pressure will be higher in container E. So at E, you're gonna have, at E, you will have a higher pressure. Okay. So at E, you have a smaller volume, with little space, okay? So the particles hit the walls of the container more often. Hit the walls of the container more often. Or you could say the particles collide with the walls of the container more often. Yeah, something like that. You could also say that. So this is walls. The walls has double L, please. So try not to lose some of your, or try not to make some wrong spellings. I think that's that about that question. We now move to the second question. It's another easy question, okay? Particles behave differently when in different physical states. They behave differently when they're in different physical states. Solids have a fixed volume and a definite shape. Gases have no fixed volume and they take the shape of the container. Describe the volume and the shape of liquids. So how are the volume and the shape of liquids? You could tell them that liquids have a fixed or definite volume. They have a definite. Sometimes you could say fixed, okay? Sometimes they usually say fixed. But take the shape of the container. Take the shape of the container. The B part says complete the table to show the separation, arrangement, and movement of particles in each physical state. The first thing I wish to say about this kind of questions is that whenever you're given this type of questions, always follow. They will give you a guide, all right? So you have to follow the guide. For example, they say liquid particles, the separation of particles is that they're touching one another. Now, if you say, if you come to solid particles and you say separation of particles, you say something that is not related to touching, it's not going to be good. All right. So rather use something similar, okay, to the vocabularies given on the table. That's one of the things I wish to say about this kind of these types of questions. So for solid, the separation of particles is that the particles are touching. So the particles are touching one another, okay? You could say touching or touching one another, whatever. So I'll just say touching. Arrangement of particles, are they randomly arranged? No, they are regularly arranged, okay? Regularly arranged. Movement of particles, they vibrate. They vibrate in fixed position. Good. Now, for gas particles, what about the separation of particles? Separation is that they are not touching. Not touching. All right, so they are not touching. The particles are not touching. That's what I was trying to say. Another student would say that the particles are far apart. They are far apart. Okay. Now, some of these answers are correct, but they are not actually found in the marking scheme. All right, so they're not actually found in marking scheme. However, the examiner can give you mark because you're actually right. Yes, you're actually right. So it's actually preferably, it's preferably you say they're not touching. Okay, it's also correct if you say they're far apart. I'll give you mark. Okay, I'll give you mark. So that's just one of the reasons I'm saying that you should be careful while answering this kind of questions. Yeah. So they're not touching. Of course, the particles are what? Far apart. That's still good. Now, randomly arranged for liquid particles. What about gas particles? They are also randomly arranged, okay? Randomly arranged. And for movement of particles, the particles actually move randomly, okay? So their movement is what? Randomly. So they move randomly. They move randomly, which of course the term is also used here, or better still, you could say they move what random and fast. Their movement is what random and fast. That's it. So you could say that, okay? You could say that. Name the following changes of state: ice turning into water. That should be melting. And solid carbon dioxide turning directly into gaseous carbon dioxide. So that would be sublimation, right? That would be sublimation. Good. All right. Thank you very much for your time and your collaboration.